Welcome to Chibuzor Mathphysics, and this is the last series in this question that we are to evaluate in probability and statistics. Here we have a question that each die in a pair is loaded so that one comes up half as often as it should. 6 comes up half again, so as often as it should, and the probabilities of the other faces are unaltered. So let x be the sum of the number of dots on the faces when the two are ruled. So first of all, we are to determine the probability distribution of x. We need to evaluate. We know that the die, each die in a pair is loaded, and 6 comes up half again after this is repeated. For you to know how we find the probability distribution table, I will refer you to our previous video where I took time to analyze the calculation of this x, because we already got the table, and the aim here is to evaluate the probability when x is odd and when it is 8 and less than x less than equal to 11. Let us have the table of distribution in this probability. So like I said, this will be a probability distribution table. If you need more clarification on this table, refer to the previous video. So the probability distribution table will be given by x takes the value of 2, 3, 4, 6, 4, 5, 6 up to 12, and all of them, when we evaluate them, we simply got some value divided by the summation of x. Of course, that's why we get 144. So let us see what we are going to do. We are going to use this table now to answer the second question. We are to evaluate the probability of x when x is an odd. So let's see how to do that. Usually, like I mentioned in the previous video, when we are taking the value of x, because here we have to find the probability when x is an odd, we are simply taking the probability of odd numbers, that is 3. According to our table, we are going to take 3, 5, 7, we also have 9, and then we have 11. All these are odd numbers. So it will simply be the probability of x. We are told that x is odd. This implies that we are taking the probability when x is equal to 3, and we take the probability of x is equal to 5. So if we take all these together, we simply add them together. We go back to our previous question. When x is equal to 3, it is 144. Add with when x is equal to 5, it is 144. If x is equal to 7, it is 144. When it is 9, it is 2144, and when it is 11, it is 12144. If we add that together, we will simply get our value will be 0.4861. Yeah, so confirm that with your calculator. It is 451. Yeah, so this is 5. Let's see, it is 0.451, 0.45. Let's just approximate that. We will have 0.45. Just have 0.45. You can even leave your answer to be 0.5 approximately. And this should be the solution for the first question. Let's consider the probability of x is 8 less than x less than equal to 11. Let's see how to do that. So we are looking at the probability of 8 less than x less than equal to 11. This would be 8 is not included because 8 is less than x, so it is the probability when x is equals to 9 plus this is plus the probability when x is equals to 10 plus the probability when x is equals to 11, because x is less than equal to 11, so x is equal to 11. If we take all this together, let's evaluate that using our table. When x is equals to 9, it is 20 by 144. 11, 10 is 16 by 144, and 11 is 12 by 144. So that should give us 0.333. 0.333. Of course, we are simply evaluating when it is 9. When it is 9, we had 9. When it is 9, it is 20 by 144. Plus 10 is 16 by 144. When it is 11, it is simply 12 and 144. This will give us 0.333. This repeating, so we simply have 0.333, and this will be our solution when 8 is less than x less than equal to 11. I hope you have enjoyed this video, and now you can be able to tackle these questions on probability and statistics. Do well to write on this comment section. The feedback, it is important, as it helps us to improve and also serve you better. Galagash, enjoy.